Okay, so question 42 is asking you what reagents are required to synthesize the following alcohols. Real quick, this is a good time to talk about what's expected of you as a synthetic chemist in this class. So this is the first example where you've not been given, where you've not been given the reactant and the reagent and have been asked to predict a product. And this actually happens quite a bit. So being able to take a reagent and a reactant, or reagent and a reactant to predict the product is only one part of a three-part goal. You need to be able to be ambidextrous in a way, although this is a three-part path. You need to be able to be given a reactant and a product and predict what reagent would make that particular transformation. As well as you should also be able to be given a product and a reagent and predict the reactant. Um, so this seems like it would be really simple to make this transition, but in reality it's extremely difficult to be well-rounded in this way. Just a kind of a metaphor for this would be you practice writing your name. Let's assume you're a right-handed person. You practice writing your name with your right hand all the time. So I'm a right-handed person, and if someone asked me to write my name, it would look something like this. Relatively legible, not too bad. So this is with my right hand. So if someone asked me to do the exact same thing with my left hand, I know how to write my name. Obviously, I know all the letters. It should be simple, right? This is me actually trying to write my name with my left hand. So if I try to do this, um, I might have to go really, really slow. Um, but obviously, between the left hand and the right hand, one looks nicer than the other. Um, so it's the same thing with doing reactions. You need to, in order to be efficient, you need to practice from multiple angles. And if you don't, you're going to get sidetracked somewhere along the way. So obviously, I hope that no one ever asks me to write with my left hand. Hope that my right hand never gets cut off or anything like that, because then my handwriting is going to look even more atrocious than it already does. Okay, so let's go through a couple of these. So you're given the alkene and you're asked to play around with a couple of different alcohols. So you know that in all of these cases you're doing a hydration. All that's different is what carbon the alcohol is going to. So we have three different carbons. So this is carbon A, carbon B, and carbon C. Okay, so we're going to either put our alcohol on carbon A, or carbon B, or carbon C. Okay, two of these are just being able to recall reagents and being able to recall whether or not they add in a Markovnikov or an anti-Markovnikov fashion. So let's just say if we added um, our OH to carbon B, then we have basically three different ways to actually form an alcohol. One is doing an oxymercuration reduction, one is doing a hydroboration oxidation, and the other is an acid-catalyzed hydration. And we already know that if we want to do um, um, a, a Markovnikov addition of alcohol or of an alcohol, we have to resort either to the acid-catalyzed hydration or the oxymercuration. Obviously, something funky is going on with this, where we have, an alcohol addition to carbon A. So let's just be safe for the moment and say we're going to prevent any kind of rearrangement, or attempt to prevent any kind of rearrangement, by going with the oxymercuration route. So if we're going to do that, then all we have to do are remember the reagents, and we're home free. So that's just going to be our mercury acetate, water, and then step 2 is going to be sodium borohydride. Okay, and again, the mechanism for how this works is not really important in my mind. If you want to know how it works, great, your book talks about it. But will it be necessary for you to memorize how the mechanism works to do well on an exam? No, it won't. All that's really required is for you to know that oxymercuration occurs in a Markovnikov fashion, and no rearrangements occur. Okay, no rearrangements. Kind of looks like I was drawing with my left hand. Okay, so then going down to the next one, we know that if we add our alcohol to carbon C, this is going to be an anti-Markovnikov kind of arrangement. So then you think back to the only other two ways that you know of to add an alcohol. One is the hydroboration oxidation, and the other one is going to be the acid catalyzed hydration. And again, or sorry, the acid catalyzed hydration gives you Markovnikov. So actually there's only one. So all you have to do now is, now that you recognize that this is an anti-Markovnikov addition, the problem becomes extremely easy. So this is an anti-Mark, and again, instead of writing out no rearrangements again, that's how I'll draw it. So this is an anti-Markovnikov addition, and this is going to occur with no rearrangements. Okay. So all we have to do is now write down the reagents. So BH3. Okay. And then after that, the THF is just the solvent. You can draw that if you really want to. Doesn't really matter to me too terribly much. It's not really taking part in the reaction. So then the second bit is going to be hydroxide and H2O2. So hydroxide and hydrogen peroxide. Those are the two reagents for the second step. And again, you don't need to know the actual mechanism for this. It's actually quite complicated. But again, if you're interested, your book does go through it. Okay, but this is what I'm interested in. You knowing anti-Mark, no rearrangements. Okay, so let's think about this top question. Obviously, something has gone on here that's really, really weird. We haven't actually added a hydroxyl group to the C or the B position, and instead we've added it to the A position. So an alarm bell should go off in your head to remind you that this means that there must have been some kind of rearrangement going on. And the only time you get a rearrangement when we're doing hydration is going to be the acid catalyzed hydration. Okay, so H2O with H plus in solution, so strong acid and water. And so I'm going to leave it at that. But what I want you to do is to go through the mechanism of the acid catalyzed hydration and try to, prove to yourself that this actually will occur. Try to figure out why you end up adding that hydroxyl group onto carbon A and not on the carbon B. And it's a very fundamental criteria. It's a very simple criteria, but it's something that you absolutely should be able to recognize. Okay. So the bit that you do need to remember here is that acid catalyzed hydration goes through a Markovnikov type addition, although it is subject to rearrangements. Okay, so this can potentially rearrange. Okay, can potentially rearrange. All right, and that's it for that. Again, try to figure out the mechanism. If you can't figure it out, talk to me, and we'll figure it out together. Okay, next question.